Hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. This is number 46. We're determining the limit of the sequence, or show that the sequence diverges. If it converges, find its limit. So we have this thing, and it's a tangent inverse. So the thing about tangent inverse is, if you remember what the tangent function looks like, let's just say y equals tan x. The tangent of 0 is 0. The tangent of pi halves is undefined. So it's got a vertical asymptote. And actually, the only two of the 6 trig functions that don't have vertical asymptotes are sine and cosine. Sine and cosine are the waves that everybody knows about. But all the other ones have an infinite amount of vertical asymptotes. And this other one over here is at negative pi halves, at least for one period of tangent, which is all we're going to need, because right here, let's say, at 1, and then right here is at negative 1, the tangent of, if that's pi halves, then this would be pi fourths, right? Can you guys see that? Yeah, you can see that. This would be pi fourths, and the tangent of pi fourths is 1. And the tangent of negative pi fourths is negative 1. That's a little off. That's fine. So the graph looks something like this. Da, 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 and da, 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 da. So why is that important? Well, because when you're graphing the tangent inverse function is literally just if you change out the x's and the y's. So if you say that x, and that's a little bit high. Let's put this down a little further. So x and y. So remember I said negative pi halves, that was an asymptote. And then negative pi fourths is negative 1. 0 is 0. Pi fourths is positive 1. And then pi halves is your other asymptote. Well, for the tan inverse, it would be 0, 0 still. Because when you inverse, you switch the x and the y, right? So if the x and the y switch here, it wouldn't be nothing would happen. But if these guys switch, let's see, pi over 2 is about 1.5. So pi fourths, pi halves, pi thirds would be somewhere in the middle, which would be about 1. I'm just kind of like guesstimating about where it would be. So if these flip, then the x value of this would be negative 1, and the y value would be negative pi fourths. You know what? Let me just put it on a different graph, because that's going to be confusing. So let's go like this. All right. So if the x value is negative 1, then the y value would be negative pi fourths. So negative pi fourths. And that's right about there. And then we have there. Negative pi halves, right, if we switch these two. So the x value would be positive infinity, actually negative infinity, because that's going down. Forgot to put a negative on that. So that's a negative infinity. So the x value would be negative infinity, meaning all the way to the left, if the y value is negative pi halves. So at the y value of negative pi halves, we'd have a horizontal asymptote. So that means it's going like this. And then it goes like this. And then you can kind of guess what's going to happen over here is that when I go over to 1, it's going to go up to pi fourths, So it's about right there. And then pi halves is our other asymptote. Okay, so all of this just to give you a visual, right? So the reason why I wanted to start with tangent is because you'd probably be more familiar with the tangent graph than the tangent inverse graph. But now that we see the tangent graph, you just flip the x and the y values and you get the tan inverse graph. And the reason why the tan inverse graph is important is because our function is basically the tan inverse graph. It just looks a little bit different. So if we follow this out, then it would be approaching, as x gets bigger and bigger and bigger and bigger and bigger, y would be approaching pi halves. And for this graph, because it's n squared, it just means that it's going to be approaching pi halves even faster, because the x is going to get bigger faster. Like what's inside the parentheses is going to infinity faster for n squared than it would be for n. Does that make sense? So this is still going to be going towards pi halves. It's just going to be going towards pi halves faster than a tangent inverse of n. And we can look at that with specific values as well. So let's say we make a t-chart out of this. So if we're using n and a sub n, it's a little laggy here. So if they don't say what the sequence starts at, then it starts at 1. And if we type in 1, let's see, what is that about going to equal? Looks like it's going to about equal point. We'll do 2 decimal places, maybe. Nah, let's do 3. Let's do 3. Because we know it's going to go towards pi halves. We know that it's going towards pi halves because that's what the other graph would be doing. So f of 1 looks like it's, and I'm typing this into Desmos, by the way, but you can do this on a scientific calculator as well, just 1 by 1, or a graphing calculator, of course, as well. 0.785. And again, these are going to be 3 decimal places. So 0.785, then 1.326, and then let's jump to 10 just to see what happens. 1.561. Okay. Now, what is pi halves about? If we type in pi halves, pi halves is about 1.571. So already we're getting pretty close. Now we did jump to 10, but I mean, it was already like 1.3-ish at 2, and that's not that far away from 1.5, right? Percentage-wise. If we go to 100, let's see what that would be. 1.571. Yeah, so now we are within 3 decimal places of the actual answer, 1.571 at n equals 100. So these are just several ways that we can show that the sequence does converge. We can say that it converges because the tangent inverse of n squared. We could say that u is equal to n squared, and then we would say tangent inverse of u we know is pi halves because of just like the graph, basically. Because we know that the graph has a horizontal asymptote at negative pi halves and pi halves, and that it's approaching that horizontal asymptote for the tangent inverse of u on a graph. Excuse me. It would be approaching that horizontal asymptote as it goes to a positive infinity, which is what our sequence is going towards, positive infinity. So that answer would be infinity, but then if you're plugging it back in, like u is equal to n squared, then it would still be infinity. It's like, oh, infinity squared is still infinity kind of thing. So that's one way you could do it. That might be potentially a little bit more formal to do it that way, to go by the definition of the graph that we know has a horizontal asymptote of pi halves. but also just looking at in values as they get bigger and bigger and bigger, they are also approaching pi halves. That's a little bit less formal to just use a t-chart. I like using a t-chart because it's really simple, but if they're looking for something more formal, you want to dive into what we know about the limit as it goes to infinity for the graph, which would have to do with its horizontal asymptote. You could also potentially do something by like taking the tangent to both sides and then using some sort of like a logarithmic limit kind of thing, but that might be a little bit crazy. That could be what your professor wants. So I don't know what your professor wants. I'm just trying to guess. So hopefully that's enough different types of ways to answer it that will satisfy whoever your teacher is. But if not, you're welcome to drop me a comment in the comments down below. And don't forget to check out my 5 math mistakes everyone makes and how to avoid them. You can check that out at Myers Mathematics, which is in the description below. Catch you guys in the next video. Blessings, y'all.